In this video, we discover how much energy and power boiling water takes using a portable power station. In this video, we'll explore 10 different pieces of gear and find the most efficient ways to boil water and the minimal energy to do so. Perfect for your next camping trip. Welcome friends, and welcome back to Katie's Camp Kitchen. The question I am most often asked is, how much energy and power does it take to boil water for different appliances? To try and answer this question, I tested 10 different appliances. I started with the original immersion coil heater, a small electric kettle, a couple of rice cookers, an induction cooktop, and a hot plate. I also tested a 3-quart Instant Pot pressure cooker, 2 different sizes of crock pots, and a microwave. Most of the testing was done with this EcoFlow Delta 3 Plus power station. The exceptions are 2 microwave tests and 1 of the rice cookers. Although this is a larger power station, many of the devices I've tested and run on much smaller power stations, as shown in this chart. Here is the power, size, and weight of all 10 appliances that I tested. One thing to note is that for the induction cooktop and the microwave, they both have inverters and can run at different power levels that you choose. This is particularly important when you have smaller power stations. I've tested these multiple times and showed them in other videos. Here's a list of other equipment that was used during the testing, like the pans and the thermometers. Many different combinations were tested. I had 10 different appliances, and I tested different quantities of cups of water to find out how much energy and power they needed. Now let's go and measure all the data for the different combinations. For each appliance, I will show all the measurements for that appliance together, and then I'll move on to the next appliance. We will move pretty quickly through the measurements, and at the end I'll have summary charts. The induction cooktop is the first appliance tested. We heated 2, 4, and 8 cups of water. 471 watts of power, 54 watt hours of energy was used to bring this 2 cups of water to boil. Next up, testing 4 cups. Keeping the same power settings, we needed 112 watt hours of energy to bring this 4 cups of water to boil. Here are the 8 cup measurements. For the 8 cup water boil test, I increased the power to 1000 watts. This was done to be able to compare with the hot plate later. Boiling 8 cups of water required 211 watt hours of energy. And here's a comparison of all 3. Now let's test the Elite Gourmet hot plate. We test 2, 4, and 8 cups of water, as well as 2 different diameters of pan. First, we do the 2 cup testing. First, I'm using this rounded pot, which I refer to as the thermos pot in the data. Achieving the rolling boil for 2 cups of water took 128 watt hours. Now I'm testing with the smaller diameter Stanley pot. To achieve a rolling boil, 138 watt hours were required. I have the hot plate sitting on a ceramic dish because it gets very hot. This is for 4 cups with the wider pot. This is the measurement for 8 cups with the wider pot. An 8 cup measurement was not made for the narrow pot because the pot only holds 6 cups. Here's the data for the hot plate and the 2 different diameters of pots. The pot that most closely matches the diameter of the cooktop uses the least amount of energy. Now let's measure 2 small rice cookers. For the Dash Mini rice cooker, 66 watt hours were needed to boil 2 cups of water. For the Aroma 3 cup rice cooker, 71 watt hours were needed to boil 2 cups of water. 115 watt hours were needed to boil 4 cups of water in the Aroma 3 cup rice cooker. Here's the data comparing the two rice cookers. 4 cups of water were not attempted in the Dash Mini because the capacity is too small. Now let's find out how much energy it takes an Instant Pot on high saute to boil 2, 4, and 8 cups of water. 2 cups required 82 watt-hours. 4 cups required 130 watt-hours. And 8 cups required 223 watt-hours. Using the Instant Pot on high saute, it took 82 watt-hours to boil 2 cups of water, 130 watt-hours to boil 4 cups of water, and 223 watt-hours to boil 8 cups of water. For this experiment, I'm using a very small electric kettle. The Joule required 49 watt-hours to boil 2 cups of water. Next, we test the immersion coil. These are found in many travel bags. Let's see how much energy it takes to heat 1, 2, and 4 cups of water. 29 watt-hours were needed to heat 1 cup of water in this Stanley cup. 53 watt-hours were needed to heat 2 cups of water in this Walmart Ozarks Trail cup. 2 cups of water in the Yeti cup took 50 watt-hours. Next, we test heating 4 cups of water in the Stanley 4-cup Walfarago cup. The Stanley pot is much deeper than the coil is long, so we did end up having to stir the water some to distribute the heat. After stirring, we were able to heat all 4 cups of water with a total of 117 watt-hours. Here's the results from testing with the coil. We needed 29 watt-hours for 1 cup of water, 50 watt-hours for 2 cups of water, and 117 watt-hours for 4 cups of water. The 4-cup container did require stirring. As a special case, I tested Crockpots, both a 2-quart and a 4-quart. These Crockpots require 100 and 200 watts respectively and are great if you want to run them in the background with your other power needs, or if you have an extra power station and some solar panels. To heat 4 cups of water, the 2-quart Crockpot required 370 watt-hours. To heat 8 cups of water, the 4-quart Crockpot required 621 watt-hours. And for our last appliance, we tested a microwave. In this case, it was an inverter microwave, but I chose to run it at its top power level, which was close to 1500 watts. And here you can see that for 2 cups of water, we needed 109 watt-hours. For 4 cups of water, we needed 233 watt-hours. Here's a summary of the microwave data. 109 watts were required for 2 cups of water and 233 watt-hours for 4 cups of water. Here's a summary of all the data that I collected. On the left-hand side, you see a list of the hardware and the amount of water that I tested to boiling. Next, you see the amount of power in watts that was required to run the device. Next, the amount of minutes it took to reach boiling. The next column is the maximum temperature in Fahrenheit that I was able to reach. There were 3 instances where we reached the point of diminishing returns and I stopped the test. These are denoted with red text. The next column is the energy in watt-hours. These were noted as we went through the testing video. And then finally, the percent remaining of this particular power station. There were 3 cases where I did not use the power station, and those are noted here. Here's a comparison of all the energy measurements versus the appliance and the number of cups of water that we boiled. This graph has some very interesting information on it. For example, if you look at the 2-cup grouping, from the left-hand side, you can see that we have several devices that used in the low 50s of energy to heat the 2 cups of water, all the way to the right where it took over 2x to heat the same 2 cups of water. In the 4-cup grouping, we also see that we have a wide range of energy used. And finally, in the 8-cup grouping, we didn't have as many items to test because of capacity, but still you can see that the induction cooktop definitely takes less energy to heat the same amount of water as compared to the hot plate. Just some final safety thoughts. The Elite Gourmet hot plate reached 500 degrees Fahrenheit, so while it is an inexpensive device, it does get very hot and you'll need to wait about an hour and a half before you can put it away. The Crockpot's exterior reached about 130 degrees. It's very important to maintain proper ventilation around these devices. Thanks so much for watching. If you enjoyed this video, please give us a thumbs up and consider subscribing. If you have any comments or questions, please leave a note below. I try to respond to every comment. Most of the gear that I used in the video is linked in the description box and the first pinned comment. One final note, I purchased all the gear and equipment in this video. I really appreciate you coming along, and we'll see you around the campfire very soon. Here are some other videos you might enjoy.